Hi, this is the first video of Math Help. Today we're going to be starting the first unit, Unit 1, which is differential calculus. The first thing we'll be talking about today is the first principle rule. The first principle rule. And this is one of the most basic principles of differential calculus. It's actually the first thing you will learn if you do calculus in school, high school. It's one of the first things you learn. Because this is what you need to to apply the more advanced steps of calculus. So basically what the first principle is, that let's say we have any given function. We'll call the function fx. So the first principle, before we do that, let's actually talk about what we can use the first principle for. So in calculus, what we do is we try to find the gradient. So we try to find the slope of the function fx. Now, if you may remember from, I believe, linear equations, if you have done these in the past, linear equations is just a regular line, right, which can be modeled by the function y equals mx plus b. The slope is given in the form of m. So what we're trying to do in calculus is we're trying to find the rate of change or the slope of any function. It can be a cubic, it can be a quartic, it can even be a quintic, it can be any function, and we are trying to find the rate of change or the slope. And when we are using calculus, one second, let me just erase all of this. When we are referring to the slope or the derivative or the gradient in calculus, we actually have, there's a specific name for that the gradient or the slope in calculus, and we call that we call it the we call it the derivative of a function. Derivative. The derivative of a function. So if you have a normal linear function, for example, let's say we have y is equal to 1 over 2 x plus 7, and we're trying to find the slope of this. Well, since we know that y equals mx plus b, and in this form the m is equal to the slope, we can easily deduce that 1/2 is the slope of y equals 1/2 x plus 7. But what if you have something that's a little more complicated? What if you have something like, let's say, once again, fx is the function. We'll say fx is equal to, maybe we can call it, let's say, x to the power 4 plus 7x. Or, you know what, let's do x squared plus 7x. How exactly would you find the derivative? How would you find the slope of this? It isn't in the simple mx plus b form that we're used to when we're dealing with linear equations. So when we're doing this, we can apply the first principle rule. And basically what the first principle rule is, it equates f prime of x. So this f prime of x is another way of writing the derivative. And the derivative is basically just saying, it's like a fancy term for saying the slope of an equation. So we can say f prime of x is equal to limit h approaches 0 so limit h so it can be recorded by limit fx equals the limit h approaches 0. What this basically means is that the limit on the f prime of x is that is when the derivative is equal to 0 over 0. That basically means that when it gets smaller and smaller and smaller and smaller, the value of the derivative will continue to get smaller as it advances. So we're just placing a limit on it so that we know that so that we can say that the value of the derivative will eventually reach 0, will be as close to 0 over 0 as possible, I suppose you could say. It's not really a good definition, but you don't really need to understand limits to solve this. So I need to write it smaller. So f prime of x, like I said again, f prime of x is the same as saying the derivative or the gradient. So f prime of x is equal to f x plus h minus fx over h. So therefore, put a therefore sign. Okay, this is the most important thing that you 100% need to know in order to solve a question using first principles. Like, you need to know this. Because this is how you will be solving your questions. So now let's apply this formula so that, you sort of have more of an understanding of how you can actually use the formula, because now you know what the formula is, but you need to know how to apply it. So let's use the equation we had before. So the equation, hold up, let's just move this up. Okay, there we go. We just move this back up here. Okay, so the equation we had before was f. Oh no, don't use this. There we go. Was f of x is equal to x squared plus 7x. So this is fx. The equation for the first principle is f prime of x is equal to limit h approaches 0 f x plus h minus fx over h. So what we have to do in this case is that everywhere in this equation, actually let's change this equation a bit to make it easier. We'll do x squared plus 7. So everywhere in this equation where there is an x, so let's solve for the first part. So the fx plus the fx fx plus h. Basically what this means is that everywhere that you see x in this equation, you replace it with x plus h. So this x squared would become x plus h. I'll write that out later. Then you subtract whatever fx plus h is by the function fx right here. Right? You take this function and you substitute it right here where it says minus fx. So it'd be minus x squared plus 7. The h remains as is. So now let's do that for our next step. Okay. So we'll have fx is equal to x squared plus 7. Now we're going to be solving it using limits. So we can do f prime of x is equal to limit h approaches 0. It's extremely important that you do include this limit h approaches 0 when you are solving equation using first principle, because if you don't, then technically it's considered to be mathematically incorrect. So even though the answer you might get is correct, if you do not have this part, the question is technically wrong in a mathematical sense. So next, what we will be doing is we'll substitute the fx plus h. We'll substitute x plus h into wherever it says x. So the equation then becomes x plus h whole squared plus 7 minus x squared plus 7 over h. Right? Then we will continue on. Once again, f prime of x, which is once again just another way of saying the derivative. Limit. We need to include this part, extremely important. H approaches 0. Now we can put this. We need to simplify this. So we'll square everything inside of the brackets. So this becomes x squared plus 2xh plus h squared plus 7 minus x squared plus 7 over h. Okay. Now, f prime of x, sorry about that, just ignore it, it's f prime of x, limit h approaches 0. So the x squared and the x squared would cancel out. Sorry, this should be minus 7. So 7 and 7 cancel out. So we're left with 2xh plus h squared over h. Now, let's go to Sketchpad. Come on. Okay. So then we have 2xh plus h squared over h. So f squared. Okay. So we have f prime of x is equal to 2xh plus h squared over h. Now I don't know why it's coming out as a rainbow. There we go. 2xh plus h squared over h. Now, if you remember factoring, since we have h common, we can factor out the h. Forgot to include the limits there, but don't do that. Just kind of in a rush. So h approaches 0. Now we can factor out the h. So h, 2x, plus h over h. The h and the h would cancel out. So then you have f prime x is equal to the limit h approaches 0, 2x plus h. Now what we can do is, since we know that h is eventually going to equal 0, we can just, the value of h will be decreasing and decreasing and decreasing. So we're not going to write this, but we can assume that h is equal to 0. So we can, in our heads, assume that h will be equal to 0. So if h is equal to 0, then we will have f prime of x is equal to 2x. If you don't believe me, we can verify this using the Desmos graphing calculator. So our equation was x to the power so it was x squared plus 7 right, that was our, and then we can find the derivative by deriving calculus. Derivative of the above function.